COVID-19 disclaimer. All participants in this project follow safety guidelines and procedures to ensure the safety of everyone. There were no in-person meetings or interactions.
Hello everyone. In this video we will be talking about and demonstrating a physics law. This law will be focusing on Kirchhoff's loop law. Our demonstration of this law will be done through the use of a circuit and batteries.
Kirchhoff's loop law can be described as the following statement. If we add all of the potential differences around the loop formed by the circuit, the sum must be zero. Here we also see the formula for the law.
For the demonstration of Kirchhoff's law, the needed materials included one breadboard, one 9-volt battery, one battery clip, two 100 OHM resistors, and a digital millimeter. Using these materials, we will be putting to the test the law and performing our own tests to support that. Now you will see the materials we put together and tested.
This is how we'll test Kirchhoff's loop law. Here we'll have a 9-volt battery hooked up to the breadboard. The red light that is seen here indicates that the circuit is complete. There are two 100 ohm resistors being used. The system begins at the battery. The current travels from the battery to the first resistor, then from that resistor to the second resistor. Lastly, the current makes its way from the second resistor back to the battery. This is the complete circuit of the current.
So what did we see there? The initial voltage of the battery was 8.28 volts instead of 9 because the battery had been used a bit before the recording. The value of the voltage decreases as it travels from the battery to the first resistor, which the value is 2.97 volts. Then the voltage further decreases from the first resistor to the second resistor, where the value is 2.31 volts. Lastly, the voltage value increases as it travels from the last resistor back to the battery, where it's measured to be 2.98 volts. The combined value of the voltages altogether is 8.26 volts. The sum calculated using Kirchhoff's formula was that of negative 0.02 volts, which is very close to zero. This net value can be attributed to a loss in voltage as the demonstration was being conducted. There is less than 1% error between the sum of the values in the circuit and the value of the battery, making the difference not that significant.
Through our demonstration with creating a circuit, we were able to test Kirchhoff's law. After conducting the experiment and calculating our values, we concluded that our demonstration supports Kirchhoff's loop law. The sum of the potential differences in the loop law came down to a value we concluded was insignificant and thus matched the results needed.